chapter of a pointer, that is memory allocation. You must be knowing that memory allocation means we have to take the memory at the requirement, maybe at the compile time or the run time. Hence, memory allocation will take an important role for execution of the program. Basically, two types of memory allocation are there. One is static memory allocation and one is dynamic memory allocation. What is static memory allocation? The static memory allocation means that at the compile time, which memory is allocated, that is known as your static memory allocation or compile time memory allocation. At the run time, how much memory is required will be taken by the decision of the compiler, that is known as your dynamic memory allocation, which means that at the time of compilation, how much memory we will take before execution, that is to be allocated, which is known as your static memory allocation. At the run time, how much memory will be allocated will be decided, that is known as your dynamic memory allocation. Means memory allocation is of two types. One is static memory allocation, one is dynamic memory allocation. Differentiate between the static memory allocation and dynamic memory allocation means what I told. Memory is allocated at compile time, and in dynamic memory allocation, memory is allocated at the run time. Memory cannot be increased while executing the program in static, while memory can be increased or decreased at the time of execution of the program, that is dynamic. Means the memory size can be increased in dynamic memory allocation, but in static memory allocation, which memory is declared, that cannot be changed. Hence, in static memory allocation, there is the maximum chances of wastage of memory, and we cannot increase or decrease the memory size. But in dynamic memory allocation, we can increase and decrease the memory size. There is no wastage of memory. How much memory we need, that much memory will be taken. No wastage of memory is there. Hence, dynamic memory allocation is better in comparison to static memory allocation. The example of static memory allocation is array, and the example of dynamic memory allocation is a pointer through which the linked list and other data structure can be possible. Hence, the dynamic memory allocation is more flexible and required for the user in comparison to static memory allocation. For achieving dynamic memory allocation, we use few methods. One is malloc, one is calloc, one is realloc, one is free. What is the requirement of a malloc? Malloc is used to allocate the memory, and calloc is also used to allocate the memory. But the difference between the malloc calloc is malloc takes a single block, whereas the calloc takes multiple blocks of the requested memory, means the required memory. The another difference is malloc takes one argument, whereas the calloc takes two arguments. By default, if the memory is allocated by malloc, it is store all the garbages if no value is stored. But by default, memories are allocated by calloc, storing the 0. Again, I am repeating, malloc and calloc both are memory allocated, dynamic memory allocated function, but the difference is malloc takes one argument, calloc takes two argument. Malloc by default store the value garbages, calloc by default store the value as a zeros, and malloc takes a single block of memory, where the calloc takes the multiple block of a memory. Malloc and calloc, which allocate the memory, suppose we want to resize the memory, we can increase or decrease the memory. Again, that cannot be possible by malloc and calloc. To resize the memory, the realloc function is used, which is previously allocated by malloc and calloc. Suppose 2 bytes of memory we have taken, now we want to make it 4 bytes. Again, malloc calloc cannot be done. It is to be done by the help of your realloc. What is the work of free function? Free function's work is which memory is allocated by malloc and calloc, means which memory is taken by malloc and calloc. If we want to free it, remove it at the end of the program, then we have to use the function that is known as your free function. Hence, malloc, calloc, realloc and free are known as your dynamic memory allocated functions. We have to discuss one after another. First is malloc. Malloc is used to allocate the memory as a single block. It does not initialize the memory at execution, hence the value is garbage, I have told. It returns null if memory is not sufficient. Suppose we allocate the memory by malloc, but if the memory is not sufficient or memory is not available, it returns a null value. What is the syntax of malloc? Whatever you do, malloc, calloc, free, realloc, you need a pointer. Without pointer, malloc, calloc, realloc, free will not work. The syntax of malloc is pointer variable means PTR, data type or the cast type means any data type, star mark. Then malloc space consumed by the data type means byte size. Suppose number of element is n and suppose element size is 2 means byte size is n into 2. But in case of calloc, n comma 2, n into 2 is one argument, n comma 2 is the two argument. Otherwise the malloc and calloc is same. Let's take the example. Suppose we want to store few elements and find out its a sum, or any calculation will be made. Then we take a pointer variable, that is ptr, which can contain any number of values. N is the number of element we decide at the runtime that we have to input. Then we have to suppose n we take is 3. What does it means? Int as the data type, star mark, malloc n means 2, size of int is 2, 2 into 2 is what? 4, means ptr takes 4 bytes of memory space. How we have to store? In case of array we are storing subscript value, but in case of pointer we have to locate it I, means ptr plus I will incremented, one location will be go on storing the value. Now we check either the memory is available or not. Suppose ptr is null, no memory is available, null equal to null, sorry, unable to allocate the memory, exit means terminate the program. But if some memory is allocated and memory is available, suppose 2 element it takes, means 2 memory locations take, ptr does not return to null. Then what happens? We start entering the value. I's value is 0, n value is 2, 0 is less than 2, yes. First location is ptr of plus I, means ptr plus 0. Why ampersand is not required? At the time of execution of the pointer values, while inputting, it automatically points to memory location, hence no ampersand is required. Suppose ptr 0, we enter 10, sum having 0, 0 plus 10, it is 10. Why star mark is given? Without star, it carries the address. With the star, that address stores what value, that value will be added to the sum. Means suppose we enter 10, the 10 will be added to the sum. Means 0 plus 10 is 10, because previous value of sum was what? 0. I incremented by 1, I becomes 1. 1 is less than n, means 2, yes. Next location is ptr of 1. Suppose ptr of 1, we enter 10, means 10 again will be added to sum, means previously 10, now it is 10 added, that is 20. Like this, while reaching at 2, 2 is less than 2, no, it comes out of the loop, some value will display. Free ptr, it means what? What the memory is allocated by the ptr, now it will be deallocated because the work is ended. At the runtime, it asks you enter the element of the array. Suppose we enter 3 element we enter, and we have to find out the sum. Means in runtime we decide how many number of element we have to enter. If we want to run this program, then move to your online compiler. If you are having, then you copy it, otherwise write the program. Then open your online compiler and start running it out. At running, it asks you how many number of element you want to enter. Suppose we enter 2. Suppose first element I enter 10, second element suppose I enter 10, means 10 plus 10 is 20 displayed. Suppose any changes in n, because how much is required, we have to take this much. Suppose 5 element we want to store. Suppose 10, then 20, then 30, then 40, then 50. How much element you want to store, you enter and get the result. Again I want to run it out, just you wait as I am running online compiler. 3. Suppose first element I want 1, second element I want 2, third element I enter 3, 1 plus 2 plus 3 is 6 will be displayed. Means at the runtime you decide how much number of element we want to enter. Same thing can be possible by calloc. What is calloc? Calloc function is also used to allocate the memory, but multiple block of memory location will take. Its initial value is 0, whereas the malloc's initial value, default value is garbage. It returns null like the calloc, like the malloc, but malloc returns the value as null if no memory is there. But calloc, it return null if no memory is sufficient, means allocated memory which is required, if not there, then it will be returning the result like null is similar to the malloc function. Means if no memory is allocated, both malloc and calloc function returns the null value. If a memory is available, then it will take it and do the respective works. What is its syntax? Similarly, pointer variable, cast type means number of elements, star as pointer, calloc, number of element, comma, space consumed by data type. If the number of element is n and each element takes 2 means n comma 2. Whereas in case of malloc, we are writing n into 2. That is the difference. Otherwise, rest is same. Suppose you want to enter n element, like malloc, we write calloc, but n comma size of int or space consumed by the data type. Suppose ptr value, n value we take 3 means 3 into 2 means 6 byte it will consume, because each pointer takes the 2 bytes of memory. If ptr returns to null, then unable to allocate the memory. If available memory is there, it comes to the if outside the if, then n times the loop will continue like the malloc. 0 is less than 3, yes, first location is ptr of 0, whatever the value you enter is added in sum. Next I incremented 1 is less than 3, yes, ptr of 1 means ptr of second location. You enter the value and add it to the sum. Again I incremented by 2 is less than 3, yes, ptr of 2 location is entered, that will be added to the sum. Again I incremented by 1, 3 is less than 3, false, it comes out of the for. Now the sum value will be displayed. Everything is similar to malloc, only difference is instead of n into 2, you take n comma 2. This step is go on changes, and the rest of the difference is malloc takes 1 argument, calloc takes 2 argument. By default, malloc stores garbage value, calloc stores 0. Malloc takes a single memory block, whereas the calloc takes multiple memory block. If you want to run this program, again moves to your online compiler, start writing the code or copy the program if you are previously having, then moves to your online compiler and start running it. See, here the calloc is written. If similarly I want to run the program, suppose 3 element I want to enter, again I want to run it. Suppose I want to run the program, 3 element I want to enter, 11, 22, 33. In the runtime we will decide and find out the sum. In this way, we verified the concept of malloc and calloc with suitable example. We input number of elements that we want at the runtime, and program is executed and output is displayed. Then what is the work of realloc? As I have previously told, if the memory allocated by malloc and calloc is not sufficient, it will be resized by the help of your realloc. How you have to reallocate? Pointer variable, realloc, ptr means which memory is allocated by malloc and calloc is ptr. New size means what the size you want to change. Remaining thing is remain same. What is the work of free? The memory is allocated by malloc and calloc will be deallocated or released or removed by the help of a free function. Otherwise, it will consume the memory. Hence, other program memory deficiency might be arise. Hence, it is the convention or advice to the user while you are taking the memory, and when the program comes to end, you should remove the memory as not required by the current program anything else. Hence the free function will be used. By using free followed by pointer variable, the memory allocated by the respective pointer variable allocated by malloc calloc will be removed. Hence all the dynamic memory allocated function we discussed in today's class. I think I clarified better, you understand. Having any doubt, kindly make the comments. Those who have not subscribed, kindly subscribe the channel. Those who like the video, kindly like the video. Try to run the program as I have run it in online compiler or turbo compiler. In the next class, we are going to discuss some of the important topics related to the pointer. Thank you. See you in the next class.